how far? I mean, how we have to be far away from the radiator to be considered as we are in the far field. Let's see. Okay. Maybe 2 or 3 wavelengths from the origin, we can easily assume that we are in the far field. As indicated over there, as 1 K equal 1, it's not far field. But if KR is about 2 or 3, it could be considered as a far field. Okay, that's interesting. What about the quadrupole and the dipole? Okay. How can I? We're just okay. And thank you. Okay, first case, I have 4 speakers. Now the 4 speakers moves with the same phase. So it radiates sound dipole-like or monopole. And then this switch makes the speaker moves, this 2 speaker moves with the same phase, but this speaker moves with out of phase with this speaker. So you can immediately feel that radiation power is decreased, right? So now you believe this. And then I can make quadrupole, meaning that phase of all this speaker, plus phase, minus phase, plus phase, minus phase. And I can do it. Right? Because it's a quadrupole, meaning that 4 guys fight each other. So radiation power has to be reduced. And then I will demonstrate. This is different phase. Okay. Now I want to. So what we learned using trembling sphere, monopole sphere, simple mathematical approach can be experimentally confirmed. Now you believe, right? Okay. How about if I have piston and a baffle. That is moving with certain velocity. And I want to know the radiation pattern over here. For example, I have okay. What if I am oscillating fluid over here? And what kind of radiation pattern you can expect over here? Let's see. No visualization? Huh? Can't see anything? You can see some radiation look like a monopole, right? Okay. What about the radiation when I have this? Many monopoles radiate. Okay, if I increase the size, you can see the wavefront radiating from this slit is different with what we observed when we have a small slit. Actually, Ka is different. For the previous Ka is A divided by wavelength was small or large compared with this. This is wavelength is this size. So if I make a very small wave, what do you see? There's a radiation from this corner and this corner and so on, right? But when I make very long wave, what do you see? You see the wave front over here, right? So that's very interesting, right? I make very you will see some pattern which is not equally likely distributed. In other words, which depends on not only R direction, R, but also in theta direction, right? So we want to see the directivity pattern due to this kind of radiation in general. Okay, that motivated us to study the radiation from baffled piston.